So there is one useful property related to the chord and the circle center, which is used a lot in solving a lot of questions related to the chords in a circle. So the property is this: the shortest line drawn from center to the chord is the perpendicular bisector. So from the center, let's say O is the center, I am drawing a line to the chord, right? If I know it's a perpendicular line, automatically I also know that OC cuts AB into two equal parts. That's why this is called the perpendicular bisector. It is perpendicular and bisects the chord into two equal parts. The shortest line from a point to a line, right? Basically from a point, if I draw a line and that has to be the shortest line, it is always the perpendicular line. Any other line I draw to the line, let's say AB from the point O, it will not be shorter than this perpendicular line. That's why we are calling it the shortest line drawn from the center. But anyways, all you need to understand is this OC is the shortest line, right, from center to the chord. Or sometimes you might say, what is the distance, right, of center from chord, or what is the distance of the chord from center? Basically all talking about OC. Then CB is the half chord length. If I know CB, I can just simply multiply into 2 to get the chord length. And OB is the radius, right? So OCB is a right angle triangle, and I can use Pythagoras theorem. OB square is equals to OC square plus BC square. Simple. So radius square is OC square plus half the chord square, that's BC square. So based on what I know, is it the radius or the distance between the center and the chord, or the chord length, so that I can do half the chord length to get BC. I need to know 2 out of these 3 to figure out the third one. So that's how the questions would be generally be framed. If I know that there's a line that is joining the center and the chord, and it is splitting the chord into 2 equal parts, it has to be the perpendicular line. If I know it's a perpendicular line drawn from the center to the chord, it has to cut the chord into 2 equal parts. One thing I know automatically, the other has to be true. That's a useful property that you can apply to solve the questions. Now, the second question, the radius of a circle is 20 centimeters and length of one of its chords AB is 32 centimeters. Find the distance of the chord from the center. As I said, that's the simple property that we discussed. This is the chord length AB, right? The radius of the circle is 20. Chord length AB is given as 32. What is the distance of the chord from the center, right? From the center, so I need to find out this distance x. As I said, the line joining the center and the chord will be perpendicular bisector, cuts into 2 equal parts. So what will be the arc length is 32, so AD is 16 and this is 16. What about OB? That's the radius that's given to be 20. So finally it will turn out to be a right angle triangle. This is the radius 20. This is half the chord length 16, and this is x that I need to find, the distance between the center and the chord. X square plus 16 square is equals to 20 square. That's x square plus 256 is equals to 400. This goes this side, 400 minus 256 is 144. X is 12. Right, so the answer is, the distance between of the chord from the center is 12. Right, all we did is just use the Pythagoras theorem for the right angle triangle. You just need to fit in the right values based on the given question, right? This is like a very simple application of this the perpendicular bisector property of the chord.